All right, let's begin. Okay, so, welcome. The last day of CMSC 201. So the final is out. You have until December 16th, that's a Wednesday, at 11:59 p.m. Okay, so why did I make this the time? I made this the time because that is the last day of the course. We can't have anyone working on anything after that. So that's it. Okay, what else? So there's 7 problems. I promised you 8, but I kind of mushed one problem together, and so it's really 7 problems. 96 points on that part of the final. And then what I'm going to do is I'll release the multiple choice questions on Wednesday. That is not how you spell Wednesday. There we go. There will be 12 questions, 24 points. So that'll get us to the total requisite 120 points for the final. So this final is actually relatively small compared to most finals, I guess, because most finals in this class are usually 200 points. So I just kind of, I stripped a lot of points out of the exam category because I felt that there's not a lot of, with the fact that, you know, things aren't in person, exams are looking more like homework pluses, right? So in a way they're, I don't know if it's better or worse. We'll have to, I don't know. We'll have to see. Okay, so, yeah, so let's talk about, let's do a little bit of review. Also, I should say that Project 3 is due tonight, 11:59, as usual. Okay, so, yeah, so let's talk about some review topics. So what do we do all semester, right? You know, what did we learn on the show? So, are any of the exam questions required to be recursive? Yes. One of them is recursive. It's the recursive one. So let me find the exam. Do I even have it pulled up? Don't know. Oh yes, here it is. It's in the same window as my YouTube stream. So, okay. There's one of them, the end days of Christmas. This one here. Oh, crap. Fixed. Okay. Let's move the sample output to the next. There we go. That's a little bit better. Okay. Yeah, so write a recursive function. Can you do this iteratively? Yes. Can you do this in one step using some formulas? Yes. On the other hand, I don't care. Don't do that. The only hint that I've given for this problem, the nth day of Christmas problem, is that you're allowed to use this formula as part of your calculation of how many gifts that they receive on that current day. So it's actually kind of cool because the answer to this problem is known, there's actually stuff all over the internet about it. But anyway, if you don't look it up, as it turns out, these numbers here are called the triangular numbers. And then when you add up the triangular numbers, you actually get the tetrahedral numbers. So the number of presents that you get, the number of presents that you get in the 12th Day of Christmas song is actually equal to the tetrahedral numbers. As you see, it's the sum of the nth day of Christmas, or, you know, of each day. So in the end, this is actually the answer here. It's just n plus 2 choose 3, or alternatively n times n plus 1 times n plus 2 divided by 6. And you might think to yourself, oh, well, I can just do that. Well, I'm requiring you to do it recursively just because I feel like it, and it's a sequence calculation, right? So it's not a terribly complicated one. It's not like a branching recursion or anything, but yeah. So let's see. Why does 6 have to return true or false? Oh. So have you ever seen the 8 queens problem? So the 8 queens problem is where you have a chessboard, right? And you want to put the queens on in a way such that they can't attack each other. Now remember, a queen in chess can attack vertically, can attack horizontally, and can also attack diagonally. So for instance, if this queen that we're right here were, say, well, okay, it would also be attacked by a bunch of other things, but if you moved it one here, then this queen could attack it on the diagonal, and this queen could attack it on the diagonal. So that's why it has to be here, right? So this, I mean, basically, I am generalizing a problem, right? This is the 8 pickets problem, which is actually way easier to solve than the 8 queens problem. Of course, you're not actually even solving the problem. You're just determining if the board is valid. So for instance here, like this picket here could attack here or here, except that they can only move 2 or more spaces, so they actually can't move here. So it can move here, and then it can move not here, but here. This picket can't move here or here or here or here, and that's why these 2 pickets, even though they're, if you remember bishops from chess, they can only move diagonally, but they don't have any weird restriction like this. This is just a problem that I assume that just isn't on the internet. Like the 8 pickets problem is just something I made up last night. So, yeah, so these 3 pickets here cannot attack each other because even though they're diagonal, they're in one space apart. And so basically what you want to do is you want to return true if it's a valid configuration of pickets, meaning all the pickets are on the board, but they can't attack each other. That's a true condition for the 8 pickets problem. The false condition would be something like this, where you see you have a picket here. This picket can't attack because they're just one space apart. These are on the diagonal, but they're just one space apart, so they can't attack. These 2, on the other hand, this one and this one, you see, picket and picket, those can attack each other. So that's why here you would return false, because the bolded pickets can attack each other, and so here the bolded ones can attack each other. Well, this one can attack this one can attack these 2, and this one can attack this one. These 2 can't attack each other directly. This one can attack this one can attack this one, and these are okay, right? There's nothing on this diagonal, there's nothing here except for this one, but this one is one piece away. So it's not a terrible what sample output? So yeah, so I made a little diagram here about where the thing can move. So I mean, this is basically your sample output, right? This is explaining, like, if you make this grid, right, as a 2D list, and you put the pickets in the certain places, then this one should return true, and these 2 should return false. Okay. Yep, and then here's converting to base 7. The reason why I did it with base 7 is because Python will do base 8 for you, it'll do hex for you, it'll do binary for you. So basically, don't use, I might even just say it in here just in case, don't use any internal Python methods to do this, right? Just use it's hard to say what I mean by that, but like nothing like int, bin, hex, oct, right? Nothing like those. I think there might be some module you can do to do it like that. I'm not sure. I'm pretty sure there is something in there, because there's always something in Python that does everything for you. Do you need to create your own problems for 6? Yep. Yeah, you do. But I gave you some samples here that you can make, right? So basically, if you wanted to make this, you would just like do something like you know, you would do something like, well, let's see if I can move it over a little bit. It'd be space, 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 picket, space, space, picket, space, space, picket, space, 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 picket. Nope, that's a C. Picket, space, space, and finally, space, 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 space. Right? And so that's how to do this one. So for instance, this would be that. Crap, come on. Right, so basically, I think you can even just copy this in if you define these two capital constants. You can just use this exact thing, right? And of course I made them all 5 by 5s just so that they would be displayable here, but the grids can be rectangular. Yeah, for 5 you're just doing base 7 conversion rather than base 8 conversion, base 2, base 16, base 10, right? This is just a base that you've probably never worked with before, but the point is that it doesn't matter, right? The algorithm is identical to the one we described in class, except instead of doing 2 or 16, you just do 7, right? So this problem is like, I mean, I think you could even like look up the code on the GitHub and it's probably, you just modify it, right? Yeah. So, for jelly bean sort, the parameter is the list of jelly bean colors, right? Yes. So yeah, so this is one example of what you'll be given, right? So, and the point is that I'm not specifying what all the different colors are, so we could have like a, you know, red, yellow one that pops up, or some kind of hybrid, or like brown or orange or lime green instead of just green, so you could have forest green and lime green. I'm not telling you what all the colors are, right? So the jelly bean colors won't be specified, but if you encounter a new color name, then it's just a new color. So there's no invalid colors. So the colors could even just be like A, B, C, D, E, F, G, H, I, J, right? It doesn't matter what the color names are, as long as if you get 2 A's, you put them together. If you get 2 B's, you put them together, etc. Yeah, and don't use dot sort. No. That's the whole point. That's exactly what this is saying, is don't do that. Don't ask a user for the list of possible colors, right? If you encounter a new color while you're counting, then that's a new color, right? So if, you know, if there's like a black one, like a licorice one, then, and you've never encountered black before, then black is a new color, you add it to your list, right? Okay. And then maybe I'll add that. All right. So I think that's just about it about the exam. I think the exam, I don't know. So this problem is causing moderate levels of confusion, but is it like a bucket sort? It's kind of like a bucket sort, yeah. It's kind of like a bucket sort. The first thing you want to do is you want to put everything into buckets, and then the second thing you want to do is sort the buckets. So that sort is probably going to use something else like bubble insertion selection. The limit of size that we're probably going to run on your jelly bean sort is not 1,000 things in this list, but 1,000 different colors would probably be the absolute max of the list of colors. So if there's not more than 1,000 different colors, is what I'm saying. The reason why is because if you're using an n-squared sort, like bubble insertion selection, it's possible that an n-squared sort will take a long time if we feed in anything more than about 1,000. So if we feed in like 10,000, it'll take a few minutes probably to do a sort on 10,000 elements. And so we don't want to wait that long, right? So the limit is probably 1,000 different colors. Okay. I think I've adjusted this. I've definitely made sure that tuples are allowed. I guess classes are allowed. But really just for the class problem. You shouldn't be doing classes for anything else just because we're only asking you to implement one function. In the forbidden method, I think I've taken everything off. I just copied it from exam 2, so hopefully there's nothing here. Yeah, let's see. Await as, I guess technically as is allowed because you can use open. Whatever, who cares, right? I'll take as out, but that's only just because it doesn't matter. And the rest of these should not be used. Let's see here. Yep, I still agree with this. I mean, really break and continue are like the big ones that we ban. You know, when you get to 341, when you get to other programming classes, you might be allowed to use break and continue. The only issue about break and continue is that it just teaches some really bad habits. Whereas, like, and since this is like the quote-unquote first programming class, I'm just trying to, like, I'm not actually terrible, you know, I think you all at this point understand that I don't like forbidden lists, but I do like banning break and continue just because it does cause a lot of really weird and bad habits. People use break and continue when they should just be fixing their code. And so I think it's a justified thing to ban it, at least in this class. You know, this class is not the real world. It's not a programming job. It's not this, it's not that. What it is it's the first programming class. So we're trying to teach good habits, and I hope we've accomplished that to some degree. That's all I can really say about it, right? Is that the forbidden list exists just because I know that there's still some people complaining about the forbidden list, and they think that you still hear people saying things like, oh, you know, if only I could use X. But what I'm really trying to do is like none of these things are the answer. So if the answer was in here, I would allow it, right? That's the whole point. It's like, if the answer was actually in this list of things, I would definitely allow it. So, okay. Yeah, and so, alright, I think that's basically it for the exam. I mean, well, I shouldn't say that's it for the exam. What I should say is that's it for me talking about the exam. I think we'll definitely have the exam explained a bunch. You know, there's so much more to do. Maybe I'll talk about Jumble a little bit if I have time. I mean, we'll have plenty of time. I know I'm just kind of rambling. So what did we learn on the show tonight? Meaning, what did we learn in this course? So, could you use recursion for lucky base? Don't do that. That's one of those instances where there's an iterative solution, and the iterative solution is way better than the recursive solution. I guess you could use recursion. I'm not going to forbid it, okay? I'm just going to say that it's better to use the iterative solution. So let's talk about what we learned. And this is kind of maybe, the whole reason I'm doing this is probably just to, A, go over stuff, and B, to talk about, you know, basically to talk about what you're going to encounter in the future, what you need to basically, what I think the whole point of this class was. So, like, what's the point of what happened this semester, right? What's the point? And so I think the point is, let me just make, can I close all these? Yeah. So, well, if you haven't read the final, then I don't know. You should check. Check it out. Check it out yourself. So, yeah, so I think the thing to learn about this class is we've learned like print and input, right? And the whole point about print and input is that's the Python way, right? Or, you know, to quote a show, you know, this is the way. You know, you've learned how to format input statements using the .format command, the little % if you want. You know, basically the whole point is that this % stuff is kind of reminiscent of C. The .format, it might be a little bit like Java, who knows. And then, you know, you can do other kinds of print and input formatting. Really, the whole point about print and input formatting is that it's probably the least interesting thing about the class. It just gets you where you need to be, right? You need to be able to input stuff and output stuff, and you can, right? And so then the other thing to talk about is casting variables. We did that, or maybe creating variables. So remember, oops. You know, in Python, variables don't have types. And so what we mean by that is not... so we have to be careful what we mean by that. So I'm going to delete that. I'm going to say, in Python, variables don't have fixed types. That's better. And what I mean by all this is that, you know, when you create an integer, so if you say x equals 3, then if you do the type of x, then it's going to be int, right? And if you do something like x equals hello there, then the type of x is going to be equal to string, right? So that's all true. So, yeah, so basically you don't specify the type. So you don't specify type when you create variables. So that's the first thing that you're going to have to get used to when you get to 202. In 202/C++, you definitely do, right? When you create a variable, the first thing you're going to learn is that you actually have to do, for instance, int x equals 3, or string x equals hello there. Or technically, you could even learn character pointer hello equals, you know, hello there, something like that. So, but you see here that there's all these different types that you have to specify before the variable name. In a way, it's more comforting because when you eventually have to do this, then you're absolutely sure, right? You're absolutely sure that whatever x is, it's going to be an integer. So unlike in Python, and I just had this conversation on the Discord with somebody, and it's a good conversation to have. It's a conversation where you talk about the fact that, you know, when you pass something into the function, so I think someone was asking about jumble, and when you pass something into a function, how are you guaranteed that the types that you think are going to come in are actually the types that come in? And the answer is, you can do some instance checking. So for instance, there's a way to do it in Python. Let me show you the way to do it in Python. Let me see if I can find my... here it is. Okay. So, lecture 26. Merry Christmas. And so, basically here, if you want to do something in def my function, and let's say it takes x, and we want x to be an integer, well, so that's a little bit of type checking. So it is something like that. You can actually specify that you want the thing to be an integer like this. This is outside of the course, but it's something that is nice. And so if you want to show that... so what this means here, let me actually just document what this means. This means that we expect x to be an integer, and it will return an integer. So what this does is it allows Python to do a little bit of extra type checking for us, which is actually, in a way, it's nice, because what we're going to do here is return x plus 2, right? And so this is going to return, you know, an integer, and it's going to return x plus 2. Okay, so, cool. There we go. And so here, if we called my function, and we called it with hello, the thing is that this right, this is normally going to break, and it does, right, because you can only concatenate string, not integer, blah, 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 so it doesn't make sense. The other thing is you notice that PyCharm is yelling at me here, and it says expected type int got string instead. And so here, if we actually did this, then it would stop yelling at us, right? So, so the thing is that there's no error that happens. If you break the type checking rules, so if you send in something that's not an integer, Python doesn't actually break. It only breaks when it gets to this statement here, where it then tries to return hello plus 2, which fails, or 5 plus 2, which 5 is a string, right? So all of this stuff, these are called type hints. And they are truly hints in the sense that Python doesn't actually enforce them. Your IDE may yell at you. Okay? So you might be wondering, okay, so how can we absolutely ensure that the thing is an integer? Well, this is how to do it. You use a band function called isInstance. Right? So if x is an instance of an integer, then we return x plus 2, else return 0. And you see here, well, I guess I haven't actually printed anything out, so maybe I'll print them. So you see here, it returns true for isInstance x int, so it returns x plus 2, else returns 0, and here you see that it returns 0 for the second case. I guess I'll do this for the last time. So we see here that this isInstance will actually make sure of types. Now you might be wondering, like, why haven't we taught it? Why don't we use it? The answer is because it's actually not. So yes, you could use type, but if you use type, then you have to do something like if type of x, whoops, opening RubyMine, I guess, is equal to int, and then we print, yep, it's an int. The only problem with this is that this is not how, I don't actually know what the actual problem is, but this is recommended. This is what's recommended. I think the reason why this is recommended is because here you have the type of a thing, and it comes out as like a class type here, and then you're checking if a class type is equal to another class type. I think the reason that this is bad is it could cause issues with inheritance. And I think this is more inheritance safe. But you'll deal with all of that in 202. No, so this works, right? There's nothing wrong with this. It just checks to make sure that the type is exactly an integer, whereas if it's an integer that's encapsulated or some kind of, it could cause issues. I think it's inheritance problems that this doesn't like, which obviously we haven't talked about inheritance in this class, so that's something that that you don't really know about yet. All right, so we talk about creating variables. We talk casting variables, right? You can cast variables using int, blah, right? String blah, float blah, bool blah, and finally list blah, dict blah, right? Those are basically your like type constructors. Well, so keep in mind that isInstance and type are both internal Python keywords. So isInstance actually has access to the underlying C code which defines Python. So it can do the type checking beneath the surface, right? So that's why type and isInstance are doing two separate things, because they're both accessing the underlying like C code. Well, let's just show something here. So animal pass class dog, which is an animal, pass, and then here we'll say if isInstance. So let's create a D, which is a dog, But then we say, you know, if type of D equals animal, print dogs are animals. So you see here, is instance of D and an animal returns true, because you see here, a dog class is actually the same thing, or it's not the same thing. It's inheriting from the animal class. And so that's why this is a bit more safe. Now you might be thinking, like, what's the, you know, that's all way beyond 2 or 1, and I agree. And it didn't print dogs or animals too, because the type of D is not animal. The type of D is dog, specifically. So, anyway, I mean, this is all just beyond Python stuff, right? So this is basically the first part of the class. You create variables, you cast variables, all that stuff. Remember how variables, so I think it's important to remember how things evaluate as true, right? So if you have a number that's 0, so for like integers and floats, 0 is false, the empty string is false, none is false, and what else is false? Empty list, empty dictionary, and also false, right? So you should create a list yourself and feed it in, right? Just like the other exams. Okay. All right, so just remember, so this is important, so remember this. Let me talk about short-circuiting again. So let me talk about what short-circuiting means. So, excuse me. Remember, if you have an AND expression, so if you have, say, my list is equal to an empty list, right? You can always test my list and then say my list 0 is equal to happy, right? We print my list is good. Else print my list is bad. So here it's going to print my list is bad, right? And why is it doing that? It's doing that because it checks if my list is true, and my list is the empty list, so it's false. And normally, if you try to evaluate the my list 0, right, you would get an index error there, because my list 0, there is no my list 0, so that's an index error. So the question here is, why don't we get an index error? And the answer is because it checks the first statement in the and it's false, which is false. And because it's false, we know, right, false and x is false, right? It doesn't matter what x is. If x were true, then it's false. If x is false, then it's false. So false and anything, right? False and anything else is false. So that's the point here. So basically, it doesn't need to check the second thing. Now, if, of course, we say, you know, happy here, then we'll say, you know, my list is good, because now the list isn't empty, so this evaluates to true. Oh yeah, if it were or, then you would get an index error. Yeah, so if you change this to if my list or happy, then we should see an index error if we delete this, right? Index error. Because, remember, false and x is not yet done, right? Because if it's true, then it's, oh, I'm sorry, false or x is not yet done. Because false or true is true, and false or false is false, so it's not done yet. On the other hand, what if you change the order of the conditions? That wouldn't help. So one thing that would help is if, oh, what, do you mean like, so this is the one way to fix it here. You can say not my list or this. And so here you can say if not my list, you can print the list is bad. And then you can say elif my list 0 is happy. Yeah. Yeah, I'm pretty sure if you just change the order of the conditions, so let's go back to that. Let's say you do this. Let's change good and bad again. So if you did, because the whole point of this condition here is to make sure you don't access the thing. So the point is that since you're doing the second, it's going to check here and get an index error before it even tries to do any type safety. And it's the same thing here if you change the order of this condition. So if you change this AND order here, you'll get the index error. So let me comment out this code. Is there like a control? Ah, that's it. So here you see that we'll get an index error because it's going to try this first before it does the my list. Yeah. So let me flip this back. So that's a little bit about short-circuiting. I think I talked about it a long time ago, but we haven't really... yeah, so basically, if statements read from left to right, and then they also read, down paren levels. So, and that's basically how they read. So they read recursively on parentheses, but they read right to left when it's just like this and this, or this and this, or this, or whatever. So, yep. And that's always important to know because that's something that's useful for pointer safety checks. When you get to C++, it's very common for you to have to do something like if my pointer and, which is the C++ way to do and. I think they also have and in C++ now, but early versions of, so it's delicate to say. The version on the GL server does have it. Some of the archaic versions don't. All that stuff. No, you're not going over the multiple choice because I am. A, I haven't written it yet, but B. I mean, the whole point of this review is to prepare you for the multiple choice. So, right. So remember that basically it's like x or like false, and x is equal to false, so it doesn't check x, and true or x is true, so it doesn't check x. So that's another way to make safety checks using short-circuiting. Okay, so after we did all of that stuff, then we did for loops and while loops. So remember there's a for I loop, so you have like for I in range of, often it's len of something. Right, so we call that a for I loop. And then we have a for each loop, which is for x in a list or a dictionary or whatever, right? Right, so we would call these for each loops. And that's just a terminology that we've kind of invented for this class. It's to some extent it's general terminology, so it's good to know it, but it's also terminology just for this class. So, and I might use these terms on the final multiple choice. So just be aware and be reminded. Okay, and so there's kind of a mixture, which we haven't really allowed, and there's a part of me that wants to legalize it, but it's always a very difficult thing. So, there's this enumerate keyword, which is kind of like a for I each loop. What it does is it gives you both the index and the element. So this is actually a really nice feature about Python, and I know that we haven't allowed it for the class, and you might think, why do you not allow it? But so you see here, this is what enumerate does. Enumerate will stick the index into the first slot, and it sticks the element into the second slot, and so it basically gives you a for I each combined loop. So now that you're out of 201, almost, you're free and encouraged to use this thing, right? It's banned in 201 because it's been banned in 201. The problem is that people are so lost when we talk about for loops that I'm always afraid to introduce enumerate. But then, towards the end of the class, there's really nothing wrong with enumerate. It's just been on the banned list all semester. So, yeah, it's one of the things that I fight with myself about. I fight with myself about enumerate. Because I love it so much. It's one of the best Python features. I just don't know when to legalize it. Okay. Yeah, that's exactly right. I mean, you can accomplish the same thing as with enumerate if you just do for I in range len. I keep doing that with range. Nope. Enumerate is illegal in 201, but encouraged after December 16th. The problem is I'm not your teacher after December 16th, so yeah. It's basically the same thing as just doing, you know, so, I mean, in general, it's like a for I loop more than it's like a for each loop. It's like a for I loop where you get to cheat and use the for each characteristics a little bit, which is always nice. But yeah. No, you can't. No, do not retake this course until it becomes legal. Just learn it on your own. So here's the secret about Python. Like, I never took Python in a class or anything, right? So I basically literally taught myself Python a few years back. Not even that many years ago. So that's the way to really learn languages. Like, right? So our goal here is to teach you a programming language, right? And Python is a language. Now you might say, well, why didn't I teach enumerate? Or all the other things that Python has? Why didn't I teach lambda expressions or this or that? And the answer is, well, lambda expressions are too complicated, and a lot of languages don't have enumerate. So we're teaching Python as if it's a generic language here. And of course you have to teach a lot of things about the language, but you also have to make sure that, like, whatever we teach you, you have to be able to go into the next language in C++ and be able to be like, oh, okay, I can do all the stuff there, just like translating from Python to C or Python to C++ kind of stuff. Like, that's what we're really trying to do here. So every language, or I shouldn't say every language, a huge number of languages like Python, Java, C++, C, Ruby, Haskell, well, not Haskell, but like a lot of, basically all the languages I've listed, they have all the features that we've taught in this class, right? You know, they have recursion, they have functions, they have variables, they have types, they have while loops, they have for loops, they have strings, they have classes, and yeah, that's what they have. Okay. But yeah, I just wanted to mention that enumerate existed and that it's the best thing ever, and then, you know, I'm the worst for banning it, blah, 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 whatever, who cares. So, okay, so what did we learn after that? Regular expressions, I mean, they're probably not going to be banned in other courses. I do recommend you learn them eventually, just because they're painful but also really useful. But, like, for instance, in 202 and 341, you're not going to really have an opportunity to use them. So it's not, like, the number one priority. That's all I really have to say about regex. Well, if you don't know what it is, don't worry about it. It ain't on the final, right? Python has a built-in RE module, which is regular expressions. So if you're ever interested, you can try it out. Python and Ruby have regex built into them, so that's always nice. Okay, so let's think about some other stuff, right? So what did we do after for loops? We did while loops, right? And so while loops, as you kind of see in the course, while loops are way less common. A while loop is a thing that's true. It keeps executing while a condition is true. But you see that it does have its limits. Like, you can write a while loop that is a for loop, so you can always say I equals 0 while I is less than len of my list, you know, and then you can say I plus equals 1, and then you can say do something here, right? And so that's the same thing as doing for I in range len my list, and you see why this is preferred, right? So this is preferred not just because it's fewer lines of code, right? It's preferred because when you see the for, it tells you that you're going to safely traverse through this range, right? One of the dangers of this kind of construction for a while loop, which I have done in the past, it does exist, it's a completely legal thing in 201. The only danger of this construction is that if somehow you forget this, or alternatively, like if you create an if statement, and then this thing gets tabbed in by accident, which it happens in C++, you can accidentally put it in another set of brackets, or in Python if it accidentally gets tabbed in or something, then you're going to have an infinite loop, right? And you won't even necessarily realize it because you'll have there's going to be 50 lines of code. You'll drag select all the code and you'll hit the tab button, right? And it'll just push everything in. You'll run your code and it'll be an infinite loop. So it does kind of save you from some of the weirder bugs that can happen if you try something like this. Generally, one of the reasons to use while loops is you want to say while not game not finished, right? You know, if you have something like this, right? So if we have some finished function that takes a board, passes, and then we have some play game function which takes a board and passes because nothing happens, right? And we have some game board, which I'm just going to make an empty list. So, you know, basically this is a kind of good while loop. It's a while loop that says you check if the game is finished, and then whatever you do, you play the game. There's probably a bunch of extra code in here. And then you come back and you see, is the game finished or not? Do this. You know, and I think one thing that I've seen that I hope that we've broken people of is it's fine to use a sentinel variable. So finished, you can set finished to true, or finished to false, and you can say while not finished, like this. And then we do stuff, and then we say if you know, x equals 2 and y equals 3, we set finished equals true. And of course you'll say something like so here the issue with this is that, and this is just a bit of a reminder, the issue with this is that it's completely legal to do this. There's nothing wrong with this, except for the fact that why are you doing this if statement? The while is already kind of an if statement, right? So here, if this is true, then we break out of this thing, so we basically just say while not this, right? So this is better than this if statement. So this if statement, and then setting a flag is not as good. Yeah, so this will set, you can do line breaks with it. You'll see that Pep8 hates you for it. They added it to Python, and then they basically made it completely unstylistic of Python. So be careful of semicolons in Python. They actually do something. So you can put a semicolon on the end of your code, and it won't hurt you. It'll yell at you for Pep8, but otherwise it's not going to do anything. But you should also be careful because you can have multiple lines on the same thing. Yeah, so basically it's always, so flags are, Boolean flags are decent ways to track things, but it's always better to keep the condition in the while loop, if possible, right? So a Boolean flag is good, but what's even better is this, right? So this is okay, but then this is better. And then you can even just say, right, you can get rid of that if statement. So this is the better way to do it. and then you don't need the finished and all of that stuff. So I would say that these are two ways to think about how to do while loops. Either you're going to do something like this, or you're going to do something like this. Sometimes you have to do this, right? Sometimes, because what's going to end up happening is you need to execute this stuff again, even if you want to set finish to true. So you don't want it to check up here. Sometimes you want it to check in the middle, and then sometimes there's other stuff. And so that's when you kind of have to use this kind of weird format where you have a bunch of code, then you check and you set it, and then there's other stuff to do, and then you have it go, and then now that finished is true, it won't do it again. So, but you have to think about which order you want to terminate your loop in. And sometimes it's possible to actually kind of move this other stuff up here, and then you don't need to do it, etc. So basically there's ways to avoid it, and sometimes it's just unavoidable. So that's why we teach it. We teach it because sometimes you have to, sometimes you can't avoid doing a weird construction like this, but usually you want your while condition inside of your, you want your actual while condition as this thing. You want to avoid this kind of construction if possible. Okay, so while loops, and then we talked about functions, right? Functions are cool. Right, so we have the def function name, and then we have its parameters. And here we'll have, and then remember when you call a function, you call function name, and then you send in a list of arguments. And so arguments are like instances, whereas parameters are like classes, right? So in that kind of analogy, because if the parameters are like, if you have some function, we would call x, y, and z are parameters. But then when you call f and you call it on 3, 56, 2, we would call 3, 56, and 2, we would call those arguments. And again, I don't, so I'm not a terrible language stickler about any of that. So I think it's completely fine if you don't really care too much about the distinction between arguments and parameters. Honestly, before I came back to programming, when I was just doing math, and when I got this job, I was like, oh wait, there's a technical difference between parameters and arguments. I'd completely forgotten. Because I just kind of use the words interchangeably, and you'll hear people using the words interchangeably, but technically, right? And since this is your first programming class, we have to be technically correct about certain things. So these are parameters, and those are the arguments, right, when you call the function. So I think that's basically, so we have, while loops, we have functions, we have for loops. So if you have this stuff mastered, right, then that's pretty good, right? Then you're good for 202, I would say. So the extra stuff that we do, basically there's two extra topics. We do recursion, and we do classes. And so it's important to understand that the class definition, right? So a class definition, when you type class, blah class, this is a class. And when you do blah class, well, let's not, maybe I was afraid when I said the word extra. Let's not call it extra. Let's call it non-basic. So not every first programming class will do recursion, and not every first programming class will do classes. If you take Java, obviously you're going to do classes from day one. If you take C++, you're going to do classes starting midway, just like we did. If you do, it depends on the language you're doing. Some languages like Java and C# are just like class-based from the start. You need to understand classes before you even understand other variable types, right? In Java, the first thing you type is class, right? So that's, it just depends. It's not always extra. But in Python, it's definitely, I'll call it non-basic, because you can do a huge amount of Python coding without typing the word class or without explicitly making certain types of classes. This is an instance of the blah. No. Okay. And then recursion, right? So recursion is an interesting thing, right? Recursion is just a function calling itself, right? And that's it. But you know that there's a lot more to how it works, right? Actually problem solving with recursion, basically the way to think about recursion is, so here's the real question. When do I need recursion? And let me put need in scare quotes, because sometimes even when a recursive solution is one of the easier solutions, you don't absolutely 100% need it, but let's just talk about when you need recursion. So you need recursion when a problem branches. For instance, if I say, I'm sitting here at a road, and there's three possible ways I can go. I can either turn right, I can go straight, or I can take this other right that takes me onto an on-ramp onto a highway. So which is the way that gets me to my house, or gets me to school, or whatever? And the answer is, well, if all you know, right, your cell phone's dead, all you know is the local information around you. You know, nothing says, this way to Eric's house, that's all. You have to search, right? You have to say, well, I think it's likeliest that maybe the highway is the right approach, so you get on the highway. But if that was wrong, then it's possible that you should have turned right or you should have gone straight, right? So, whenever a problem branches, that's a big hint that you might need recursion. You might also need recursion, or let's say you want recursion when it's easy to break a problem into sub-problems. So let's hope that this all types out. Yep. When it's easy to break a problem into sub-problems. And so you can eventually understand the sub-problems, right? Those are your base cases, right? Yeah, so that's the thing, is like if a problem ever branches, even if you know how many times the problem is going to branch, a lot of times you have to use recursion because an iterative solution just won't quite work. Unless you count a stack as iterative, which let's just pretend that we don't, because basically recursion provides you with a stack, and a stack using the stack data structure would provide you with the stack, so either way you get the stack. So, and basically any kind of backtracking probably would be helped with recursion. So that's like the three things that I would say is like, and I know that these aren't really like hard and fast rules, but it's the general way to think about something. So if a problem is branching, you probably want some kind of recursive solution where it's easy to break a problem into sub-problems. So for instance, if you're doing like a, say an image algorithm that's looking for faces in a picture, right? It's maybe possible that what you would do is you would say, do I find any faces in this part of the sub-picture? Do I find any faces in this part of the sub-picture? Or this part, or this part, right? And you only look at small little boxes to actually do the face checking algorithm. And everywhere else you're just saying, break up this giant image into a bunch of smaller images, which you can then look for faces in, for instance. Or in a grammar, for instance, when you're breaking a problem, like when you have a sentence that has an appositive on it, meaning when it has, it's like this sentence, comma, which is a great sentence and there's never been a better sentence, comma, this sentence being the subject, and then over here we still need a verb and all this other stuff. So that stuff can be, a lot of language parsing is recursive, right? And it's recursive because there's a rule that says you can always just add on another appositive. So for instance, you can say like, this sentence, which is a good sentence, a sentence, so that was garbage. set of words, right? A word being a collection of letters. A letter being a fundamental block of language, right? Not even sure, this sentence is now complete. So the thing is that if you were going to actually look at this sentence and put parentheses in where they should be, you'd have like a set of parentheses here, and then a set of parentheses like here, and then another one here, and then another one here, and then you would have a bunch of end parentheses here, so like 1, 2, 3, 4, something like that. So a lot of language processing is definitely recursive. So there's a lot of problems out there that need recursion in order to be able to guarantee a solution. Like the phone networking problem, so the secret is that our project 3 is actually really what I'm telling you to implement is something called a depth first search. And our switchboards are an object called a graph. So the CS graph, not like the XY plane. A graph is a collection of nodes and edges. And so the switchboards form a graph. And so your solution was probably a depth first search of that graph. And so that's definitely something that's either recursive or you have to use a stack. And so that's the key here, right? So the key here is that you need recursion when you have a complicated problem, but the subproblems, you can easily break it into subproblems, and then the subproblems are easier. So that's kind of the point there. So remember the types of things, the really important things in a class are that classes have, in here, remember that this method is called the constructor, and it runs whenever the class is built. I don't know why it's delayed so much. Let me see if I can actually just save this document here. Cancel. 2, 1. Okay, so hopefully it'll speed up a little bit. I think maybe I need to close in Inkscape. I've had it running for too long. So this is basically what I really want you to understand about classes. And also that in Python, there's the thing called self. That's the other thing I want you to understand. So self is a reference to the calling class. So for instance, if you have a method, right? So if we have some other method here, right, self is, So what I mean by that is that when you call myblah.doThing, right, with the value of 3, then what Python does is it actually translates it into doThing of myblah and 3. And so that's why self is this first parameter. So whenever you have a dot like this, the dot actually, it's a little grammar rule in Python that says using the dot like this, actually what it does is it takes this thing and it shoves it in as the first argument of this function, right? So really, in a way, classes in Python are almost not even an unified object. What they are is that you have this keyword here that allows the dot operator to work. Basically, the blah class allows this dot operator to say, well, if you get something that's a blah class, and you have a dot after it, then you look up the function, and then you flip the order and pass it into the function, right? So this function is kind of its own thing, right? And so it's a little bit less unified than in C++ or Ruby or some other languages like Java. But on the other hand, it's fine. And there is, so is a self in other languages. Like, for instance, in Ruby, it's actually just the @ sign. In C++, it's actually a keyword called this. And the this keyword is actually, it's not a reference to the object, it's actually a pointer to the object, which means it's not like self, it's actually the memory location, basically. So you actually have to do something called dereferencing in C++, where in C++ what you're going to have to do, actually maybe it's just because this thing is too big. Let's see if this fixes it. So in order to fix that in C++, you actually have to do this, star this, which is something called the dereference operator. What that's going to do for you is it's going to, it's going to change the thing from a pointer. So it takes a memory load and gives you basically self. Yeah, in Java, everything is a reference, so there's no pointers in Java, so Java is just this, right? And you don't have to worry about the dereferencing business. So, anyway, oh, that's just because that text box was so big. Anyway, so, yeah, so that's basically, this is my review, and the reason why this is my review is because I think this is what, when you ask yourself the question, what did we learn in this class? You should say, I learned variables, print statements, input statements. I learned casting, loops, functions, recursion, classes, right? And maybe file input output, which I haven't talked about. But yeah, so those 9 things are the things from this class, right? Print input, casting, declaring variables, for loops, while loops, functions, recursion, classes, file IO, and whatever else I forgot. So, so yeah, so that's fundamentally what this course is. You see, first I count to, hex and binary. Yeah, I kind of taught that in this class. So the problem with teaching it is that normally on a final we always ask. So, you know what? I am not putting no asymptotic analysis is on the final. I think it's good to look at the lecture on it and just kind of understand generally about the idea that as you increase the size of the input block, whatever the input block is, if it's a string, if it's a list, if it's a dictionary, you must also determine the ratio of the increase of runtime. So if the increase, so for instance, if you multiply the amount of things by 10 and the runtime goes up by 100-fold, then what that means is that you have like an O of n squared algorithm. If you have something where you increase the runtime by a factor of 10 and the runtime actually just goes up by a factor of 10, then that's a O of n algorithm, right? Because if you increase something by a factor of 2 and it goes up by a factor of 2, then that's literally going up as n. And then the most famous one in computer science is the O of n log n algorithms. They're kind of the most, I should say, they're the ones that people mostly try to achieve, right? So the best sorts, well, I shouldn't say the best sort, well, I'm going to say the best sorts are really O of n log n. You could say that bucket sort or radix sort are O of n, and sometimes they are, but there's actually a secret hidden factor, which sometimes the secret hidden factor is often about the size of log n anyway. So I actually think to some extent, you can argue with me, but I don't care. What else should we say? I don't really know how much we're going to have about hex, binary, decimal, maybe even octal. Is it going to be on the final? I don't know. The issue is that it's very hard to test online. Okay, so yeah, it's very hard to test it because normally on the finals we just have people convert, right, from one to the other. But here's the problem. You can always pull up like a Windows calculator and you set it to, I guess, maybe programmer mode, and then you just type in a number, right? You're like 52. And so it's binary 0011011, 0100, octal 64, decimal 52, hex 34, right? You could type in 281,325, which I didn't type in, and you see all of the calculation is done for you. You could do, or you could switch it to hex and be like AAEEFF, right? And then it does all the conversion for you. So you see the problem, right? You see the problem with testing this out. I have no interest in testing something that you can literally pull up Windows Calculator and get all the answers. And then there's more theoretical questions about that stuff, but that all goes into number theory, right? And I don't want to make this a number theory class, though. Well, actually, that's not true. It would be cool to make this a number theory class, but it isn't. So it's not a number theory class. Just remember, right? I think the only thing to say is remember that you've seen some asymptotic analysis. So don't pretend not to know, don't pretend not to know what that is. And then the other thing to say is I'm not really testing on a binary, decimal, octal, hex, whatever. But also, don't forget it. Okay? So if you ever need to, you can refer back to the lectures. All right, I think... So... All right, everyone. I think at this point what I need to do is make the font 75, and I need to say something like, hopefully you learned something this semester. Thank you all, especially those of you who are watching it live. I definitely thank you guys for watching. Thanks for your patience this semester. I don't think it's actually gone that badly overall. I mean, overall, it's gone okay. I wish you success in CMSC 202 if you go on. I think that hopefully, remember in your future if you ever need to use Python, even if you're not a CS major, hopefully you have a head start. And let me promise you that a lot of people now are using Python who are not called programmers. So just be aware of that. If you hated programming a lot, then make sure you find a job that's not going to become a programming job, even if you're hired as an accountant or a mathematician or an engineer of some kind. But yeah, Python is very popular now, so it's a great language to know. All right. Yeah, I wish you success in your future. Have a good final exam period. I'll be around on Discord, as I always am. And that's it. So, all right. Signing off. Outro, last time.